I want to welcome our guest. He is Professor Shai Shalev-Shwartz, the Chief Technology Officer of Mobileye, and he is joining us virtually from Jerusalem. Professor Shai, good to speak with you.
Thank you. It's a pleasure to be here.
So in the big Gen AI conversation that's been kicking around and gotten everyone excited and hot and bothered over the past year, automotive has almost become kind of a forgotten piece of the discussions. But I want to be really clear because some form of AI is in most vehicles today, and it has been for years, if I understand correctly. Mobileye, your company, makes software and hardware for cars, including driver assistance systems. So briefly tell us the extent to which AI is currently being utilized in your products. This is, a short opportunity for you to give a commercial.
Yeah, sure. Thank you. Almost every car out there today has AI inside it. Many of these cars, roughly 100 million of them, have a Mobileye chip inside the car. This chip is connected to a camera that looks at the road and basically supervises what human drivers are doing. This is called safety features, ADAS features, advanced driving assistance systems. So basically, the camera looks at the road and recognizes that you are too close and you're going to hit the car in front of you. And if it is needed, it will even initiate an emergency braking or keep you in the lane. I think that the automotive industry is one of the first usage of AI in real production.
Right. This is auto safety being one of the most important applications of AI in your industry. Shai, growing up, I kind of thought that we would be traveling like the Jetsons by now, by 2024, right? In self-driving cars that fly around and zoom around and there would be no traffic. We don't have either of those right now in 2024, and it doesn't look like it's going to happen anytime soon either. You've come up with a way to classify the different stages of autonomous vehicle progress. And what you just described to us with the Mobileye products in cars, with helping us stay in the lane or making sure that the car brakes if there's an object in front of us, that's what you call eyes on and hands on. These are just functions that are built into the car, right?
Yes. So we thought that the taxonomy of different levels of autonomy was intended for engineers, and we wanted to come up with something that consumers can figure out and understand what's really going on. So the first question is, who is driving? Either the human is driving and the machine supervises the human, or the machine is driving. Now, if the machine is driving, it can be the case that the machine is still not good enough. It can drive, but maybe not good enough. So the human needs to supervise the machine. We called it eyes on. The hands can be off. So the machine is driving, but the eyes of the human should be on the road and supervise the machine. The next level is eyes on and eyes off, but there is still a driver in the car. So at some, roads, maybe the machine can drive itself and the human does not need to supervise the machine. But not always. So we need a human driver with a driver license in the car, but at times, say on a highway, the machine can drive itself and the human can do his own things. And the next level is that there is no driver at all in the car. We call it robotaxi. And then there is no eyes, no hands, and no driver in the car.
Okay, we definitely have not gotten to that point yet. But when it comes to eyes on the road, eyes on and hands off, where the driver is sitting there but doesn't necessarily need to be grabbing the steering wheel and can be distracted by, for instance, in my case, nagging my children about doing their homework in the car. That kind of situation, is that something that you can have in a conventional gas-powered vehicle, or is that something that's only available in EVs? How much of autonomous driving is tied to the broad adoption of electric vehicles?
There is actually no relation at all with electric cars or a regular car. The systems can be on either. It sometimes helps to have an electric car for the sake of cooling the computer. this computer may got heated, and it is a little bit easier to cool them in an electric car because there is a cooling machine anyway for the batteries. But beside that, this is solvable. This can work on any car.
Okay. I would like us to talk a little bit more about the eyes-off, hands-off stage that you were talking about, the third highest level, I suppose, that we haven't gotten to yet, where you can take your eyes off the road as a driver, you can take your hands off the steering wheel, you don't even have to be sitting there. You could just be the passenger in the back. These are robo-taxis, as you mentioned, and if I go to San Francisco and I see a Waymo vehicle on the road, that would qualify as an eyes-off, hands-off situation, right?
Yeah, this is actually no driver in the car at all, but there is something intermediate product, which is there is a driver in the car, but it can do his own things. And this is very interesting because on one hand, it can be very useful. So suppose that only on highways, you can do your own things. You can watch a movie, for example, or you can answer to your emails or spend your time on social networks. But when you are going to an urban area, then you need to have eyes on back on the road. Even though it's not a fully autonomous car that can drive everywhere, it's a very useful system. Many people will enjoy it a lot because most of our commute is either on highways or in traffic jams. So if we solve only highways and traffic jams with eyes off, it's a very, very useful system. Okay, and this can reach consumer cars. And actually, we are going to have this product out in 2027, around 2027 with Audi.
With Audi in 2027. That would be in Germany. Is this something that we're going to see in the US in 2027?
Yeah, everywhere.
Okay, I look forward to that day. What are the biggest pitfalls to getting to that point, Shai, to getting to eyes off and hands off? I mean, is the system still at a point where it still is learning to distinguish between, and I'm making this up, between a person and a tree? I mean, how far away are we in terms of the technology and the training?
So the methodology that we are using is basically to solve all the problems even before we get to eyes-off system. So today, there are cars equipped with Mobileye system with surround computer vision that can drive everywhere and is not confusing between a car, a pedestrian, or a tree. But the issue is how accurate are these systems in edge cases. And this is really the big issue. If we think about it a little bit more generally, then there is something very unique about using AI for self-driving cars, because we have a very strong AI-based systems. Take, for example, ChatGPT, a really amazing system, very, very sophisticated, relies on a very, very sophisticated technology of AI. Mm-hmm. But in terms of the precision that it must have, it's not very high. Okay, it makes mistakes, and no big harm done by the mistakes that ChatGPT is doing. Okay. On the other hand, we have systems which requires a really extremely high precision. For example, airplanes. Okay, but are not relying on very sophisticated AI. They rely on traditional engineering. What is unique about self-driving cars is that on one hand, it must rely on AI, and on the other hand, it requires an extremely high precision, like those of airplanes. Now, you can ask, why do we need AI? Why do we need to rely on AI? Why can't we build self-driving systems similarly to how we build airplanes with good old engineering? The reason is that self-driving cars are acting in the real world, interacting with humans. So if you are riding on roads that were designed for humans, you must act like a human. And for that, you need a very strong AI. So it's not like an airplane that is flying high in the sky that can do its own things. Here, we need to interact with humans. So we must combine both the high precision of airplanes and AI. And this is very difficult for AI systems because AI systems are built on statistical tools. all the modern AI systems heavily relies on statistics. And in statistics, we have the problem of edge cases, because if you are 99% correct, it's not enough. It's not enough for a self-driving car. You need to be 99.9999999% correct. And the real challenge about self-driving cars is how to reach this high level of precision with a really sophisticated AI system.
So if progress towards self-driving cars is going to be done in stages, it's going to be incremental, a lot of that will rest on training the AI. And in speaking to experts in the tech field, namely Ed Ludlow, who I spoke with before this panel, he was saying that Mobileye's take on this is that you have a scale that no one else really has. Prior generations of your chips, the systems on a chip are in cars all over the world, across different cities around the world, and in different types of environments as well. And the data that you are gathering, therefore, gives you a big edge in training the next generation levels of autonomy. But then you have a company like Tesla, for instance, and they have the same argument, and they're using a vision or camera-based technology, while Mobileye is trusting in a multi-medium sensor suite. Who's right in this situation? Is Tesla right? Are you right? And why?
So let's go one step back and ask what is needed in order to build a self-driving car. So let's take inspiration from human drivers. We have eyes. It's like cameras, right? Mm-hmm. We have a brain that processes what we see and makes the decisions about how we are going to drive. And we have hands and legs in order to act to move the steering wheel and the throttle and the braking system. So similarly, in self-driving systems, we have the sensors, we have the brain of the system, which is the compute and both the hardware and the software, and we have the actuators. So let's put aside the actuators because it's a solved problem and focus on sensors and brain. Mm-hmm. So for sensors, we agree with Tesla that the main sensor is computer vision. Why? Because roads are built for humans and humans have eyes. Humans don't have LiDARs and humans don't have radars. They have eyes. So the roads are built for humans, so let's use something similar to humans. So for sure we want cameras. The only question is it enough? Are cameras enough? Now, maybe there is a claim that in the long term, just by focusing on the brain, cameras will be enough. But first, we are not there yet. Not only Mobileye, but all the research and industry are not at the human level in understanding computer vision, in understanding cameras, in understanding images. So maybe we will be there one day, but currently we're not. The second problem is that maybe human level is not enough for self-driving cars. Because if we can be better than humans, superhumans, why don't we do it? We want less car accidents. We want to save human lives. So our goal is to be better than human drivers and not just reaching human driver capabilities. And other sensors help a lot in being even superhuman, in being better than humans. So this is about the sensors. Mm-hmm. Now about the brain itself. So here again, the question is, what should be in the brain? And one component or major component is of course AI. But also in AI, there are many, many different methods in AI. There are convolutional neural networks, graph neural networks, transformers, autoregressive models, model-based nerves, many, many, many different buzzwords that you can hear and people are using all around. And the question is, what is the best approach for building the brain for a self-driving system? And our claim is that there is no single approach today that is really enough for reaching the high accuracy that is needed. Instead, we take inspiration from aviation, from how you build airplanes. And the way to reach a very, very high accuracy is to build several systems to solve the same problem in many different ways, mm-hmm. and then combine the results. And then you get redundancy. So even if one system fails in one situation, maybe another system will save you. every system, every approach in AI has advantages and disadvantages. And only by combining many approaches, you can reach the high level that's required by self-driving systems.
And that is something that will take time, as we've seen, and maybe will take longer than you expect. This is Bloomberg, so we're concerned about the economics of things, the cost of things. When it comes to getting to eyes off and hands off, what kind of costs and what's the cost basis involved? Does getting there soak up all the margin in hardware and software development? I mean, we could develop the technology at scale, but if we do so unprofitably, there's not much of a use case for it.
Yes, of course. So the main game here is how to reach a system which on one hand is capable enough, but on the other hand is economically viable. And the approach that Mobileye is taking for reaching there is combined first on camera-centric systems. So the main sensor should be cameras. Why cameras? First, they are the best sensor for driving because roads are built for humans. But moreover, cameras are not very expensive. As I said before, we do need more sensors in order to reach the high accuracy. But if the main system is based on cameras, the other sensor can be of a reasonable cost, and we can reach reasonable cost for the entire system. The other aspect of how to reach economically viable eyes-off, hands-off system is by building our own chip and having very, very tight integration between software and hardware. Again, if you take inspiration from the human brain, our hardware and software were evolved together. And this is how you get efficiency and economically viable solution. If you just take an out-of-the-box compute and you have some software, then matching this software to the computer, you must have a very, very strong computer, but then it will be very, very expensive. By designing your own hardware and software and tailoring the hardware exactly for the requirements of the software, you can reach economically viable solutions for this very, very challenging problem.
So isn't that what Apple was trying to do? It tried to create its own software and create its own hardware. It spent about a decade. It spent more than $1 billion. And then after all was said and done, it cut its losses and said, no more, we can't do this. I know that you didn't work on that, but from where you sit, what went wrong there?
Well, I don't want to talk for Apple. I will leave it for them. But what I can say is that this problem is really, really challenging. Many companies tried to ride on the wave of or the hype of self-driving, and many failed. Mobileye exists 25 years and has a huge amount of experience, and the problem is really, really difficult. So even strong companies which are really, really capable, and Apple is, of course, a very capable system, can struggle with this hard problem. You need really a focus on solving this problem because the edge case, again, the uniqueness of combining a very sophisticated AI together with the extremely high precision which is required is a really challenging task, and you need expertise in this challenging task.
Yeah, no, I like the way you put that. I guess the concern is for people who are not intimately involved in the industry is that self-driving vehicles in the end can look like a good idea, but not necessarily a great business. It's something that could be done, but at great cost. And if it's at great cost, then is it something that's economically viable for just any company that's interested in doing it, or only a certain number of companies that already have built-in expertise?
So again, you can take inspiration from Mobileye and see that we are a very good business. We are making money and we are profitable. But in order to reach there, you need to understand the business. And working with cars, you need really optimization of your cost. And it's very important to match the cost of the system with the usefulness and the level of performance that we need. And this is the expertise of Mobileye. You see it in our success in the ADAS business, in the base ADAS system, where we have something like 70% of market share. And the reason it's so difficult to compete with us, again, because we have our own chip and our own software, and bundled together, they give a great combination of performance on one hand and cost on the other hand. And we are doing the same when we are going to higher level of autonomy. So the supervision system, the system that is eyes on and hands off, which is already in production on hundreds of thousands of vehicles, is also from this family. It's a good business. The cost of the system is a good fit for what people will pay for it. And when we go higher to eyes off, only on highways and in traffic jams, again, the cost of the system is designed to meet what people will agree to pay for the system. And actually, even when you are going to robotaxis, so as you mentioned, there are robotaxis already on the road, but it's not clear that the companies that operate today robotaxi are economically very, very successful in this business. We are working on robotaxi, and the way we tackle it is by collaborating with other companies with Volkswagen, and by fitting the cost to the product. This is how you make a good business.
As we end this conversation now, we are in our final minute. All our attendees are here listening to Gen AI and the advancements taking place in this space. What's the single most important advancement that you think is needed in Gen AI that would impact self-driving development in a material way?
So I think that Gen AI, and it's not only Gen AI, there are the pace of revolutions that you see in AI is really amazing in the last 5 years or so. It's a self-supervised learning. It's an auto-regressive model, meaning that you are predicting the next token one at a time, like you are doing with a large language model. You are predicting one word at a time, and this is how you train the system, and you train them based on self-supervision, so you are not using supervised data. Nobody gives you what is the right answer. You just try to predict the future of tokens based on what you see, as well as generative models for images and videos. You can imagine how important this would be in order to reimagine edge cases for self-driving, so you can create dangerous situation without having any danger. Going also to the modern tools for search. So again, we have, as you mentioned, a huge database of images that we collected over 25 years. Now I want to find some edge cases in my database. How do I do it effectively? How do I search in images? Again, modern machine learning tools can help us do it. Maybe to give, so there are really amazing opportunities here. Maybe I will mention just some of them that affect the very basic systems, subsystem in self-driving. So let's talk about the problem of predicting where are the cars around us. So we are driving in a highway and we want to find all the cars around us. Obviously, this is one of the most basic problems in self-driving systems. So previously, what was done is a single camera that looks forward in the image, and then you need to know for every pixel, you need to know if it belongs to a car or no. But now you want surround images, so you have problems of matching different cameras, and how do you match objects that you see in different cameras to the same object? And this is a complicated problem, and you can work on it by writing code that takes prediction from different cameras and glue them together. But with modern AI tools, you can do much better than that. You can take all the cameras together in an end-to-end manner, feed them to a single deep learning system, and then output all the cars around us. So these are things that are very relatively easy to do today with modern AI tools, but were much more complicated before.
Shai, I really appreciate your taking the time to speak with us from Jerusalem. It's Professor Shai Shalev-Shwartz, the CTO of Mobileye. And I just wanted to give the results to the poll that you guys all participated in. 91% of you say that you believe AI could help get to full autonomous driving. 9% say no. Thank you so much.
Thank you.